We can have exponential growth models, but in actuality, usually there's some kind of limit. Things don't just grow and grow and grow forever. So, say you have, a pond, and you have little fish in the pond, and you've got a few fish in there. And it's a nice pond, and the population's growing and growing, and it's an exponential model. But eventually, that pond is only going to hold so many fish. There's only going to be so much food supply, and there's going to be a limit to how many fish you can have in that pond. Well, this is modeled by what is called a logistic growth model. And we have this function f of t, so it's over time. And then it's kind of complicated, that model. It could also be written a, so the amount, c over 1 plus lowercase a e to the negative bt. Now, a, b, and c are constants. And we don't know what they are. Other scientists figure that out for us. And b and c are both greater than 0. Okay? Now we do have an opposite sign there in front of the b, but so that you know. Okay, and t is still time. They call c the limiting size. So it's like the maximum you could have. So say you're tracking the flu or something, cases of the flu, and in your community, it's a closed off community, you only have 100 people. Well, then at most, you can only get 100 cases of the flu, right? Okay, so that's the limiting size. Graphically, what's happening is you have an amount that you're starting with and it's growing exponentially, but then at some point it starts to level off and it approaches this asymptote. That asymptote is y equals c. That's the limiting size. So it's not going to go over how many it can. Like like I said, if you're counting cases of the flu, you can have more cases than the number of people. Okay. Um, so here's a graph, number of new coronavirus cases. So they did this recently, um, fairly recently. And these are the dates in 2020. So they're tracking it in March. You're starting at March 14th. And then this is the number of cases. Okay. So the graph above shows the number of new coronavirus cases in the United States for 7 selected days in 2020. The function, another mistake, the function models the number of new coronavirus cases in the United States f of t, that's the number of cases, t days after March 14th. Okay, so we're counting days for time. So here's the model right there. Use the model to determine the number of new coronavirus cases on March 14th. So on the actual day that we're starting. Well, if that's when we're starting, then t is equal to 0. We've gone no days past 2014. So back in 2014, what was the number of cases? So I might have a little trouble with the scrolling here. So we're finding f of 0. So 26,462 divided by 1 plus 62 e to the negative 0.53 times 0. Now, anything times 0 is going to be 0. So now I want to write underneath. 1 plus 62 e to the 0. But e to the 0, we know that's just 1. So now I have 26,462 divided by 63. So I'm going to put this in my calculator and round to the nearest case. Okay, so we're looking at number of cases. And you can put it in your calculator. So it looks like we're getting about 420 cases on March 14th. It was 2020, right? Okay. Yeah. All right. So then it says, oh, they want to know, is this an overestimate or underestimate for the actual number shown in the bar graph? Okay. So where was that bar graph? Okay. It says 414. There were actually 414 cases. So we had 420. So this is an overestimate. by, I think it was 414, 6 cases. Okay. All right, so that answers that part A. And now what does it say? Use the model to determine the number of new coronavirus cases March 24th, 2020. So that means T is 10. 10 days have gone by. And so now we're going to figure out part B, F of 10. So we're plugging in 10 for T. Take our formula and we put everything in. Okay, so on our calculator, let's do a little bit of handwork here. Okay, so multiplying by 10 would just move the decimal place 1 over. Now, when we put this in our calculator, we'll have 26,462 divided by, you're going to have to open the parenthesis, 1 plus 62, and then you're going to get your e to the x button, and that's going to be a negative 5.3. You're going to close that off and close it off, and we'll see what we get approximately. Okay, so put that in your calculator. Okay, so I put that all in, and on my calculator, I got 20,208. So there were about that many cases in 10 days. Wow, it went from 400, around 420 up to 20,000. Okay. Then they want to know, is it an overestimate or underestimate, and by how much? So I have to go to the chart to find that. So where was March 24th? 20,341. Oops. 20,000. Okay, sorry about that. Bouncing all over. So actual was 20,341. I think that's what it said. And so this looks like an underestimate because we were saying only 20,208. And then what's that going to be? Of an underestimate of about 133 cases. Okay. And then finally, part C. According to the model, what is the limiting size of F of T, the number of new coronavirus cases in the United States? So remember that's the C. This is the limiting size. So this is part C, but that doesn't have anything to do with the C in the formula. It was 26,462 was the limiting size. So the number of cases. Okay.